Hello everyone, my name is Shenouda, and I'm a student at Oresko Community School. For this year's science fair project, I decided to research and experiment what duration of ultraviolet exposure kills the most amount of bacteria. Ultraviolet light can damage DNA molecules. If a cell's DNA is not able to repair itself in time, its mechanism can eventually damage and die. How much ultraviolet light is too much for a bacterial cell? This project looks at the effect of short-term ultraviolet exposure and long-term ultraviolet exposure. I hypothesize that the longer exposed the bacteria to the UV light, the longer the amount of bacteria will decrease. So basically, the more UV light is exposed to the bacterial plates, the more colonies of bacteria will decrease because of the DNA's damage and mutations. Did you know that the air you are breathing right now is full of bacteria? When we often think of bacteria, we often think of something that's harmful for our body, or something that may cause severe danger or infections. But bacteria can help us in our immune system. The primary use of bacteria is to help us digest and break down our food. The question for this science fair project is to find out whether exposing bacteria to UV light can cause a direct decrease in the amount of bacteria exposed. If the bacteria is killed, how long would it take to do so? I believe that exposing the bacteria to the UV light will take the most amount of time, and the more bacteria will decrease if the more the UV light is put onto the plate. For example, if we have an amount set for a plate, the more amount that we increase the light exposure, the more bacteria will decrease. For my independent variable, I have the time of exposure to the light, the duration of the UV light to cause a direct decrease or kill the bacteria in Petri dishes completely. For my dependent variable, I have the type of bacteria grown, the amount of bacteria grown, and the growth rate of bacteria. I have the same amount of bacteria grown into every Petri dish, so that way the same amount of bacteria and the same type of bacteria can give us the same result and an equal result. For my controlled variable, I have the temperature, which will be set at 37 Celsius, and the amount of agar, the time bacteria growth, the distance of bacteria from the UV light. I will be using a foil pan to determine the distance, so that way all the distance from the UV light and the bacteria plate is equal. For my materials, I have 15 nutrient agar plates. These plates, I purchased them from Amazon, and you can also get them from Walmart or any place. I also have a foil pan. A small foil pan is fine as long as it's able to fit in the UV light. And you will obviously need a short wavelength UV light, a sterile swabs to help us gather our bacteria, so that way the bacteria can grow and we can do our testing. And for protection, we can use protection goggles and gloves. We will also need a timer or a clock to record and find out and make sure that the time that each plate is exposed to would be at a correct time. And a permanent marker to label our plates. For example, if we have a plate that's exposed for 15 seconds, we can write 15, so that way there won't be any mix between plates and the results. And a warm location to keep the plates. Room temperature is fine. Any warm location so that bacteria can grow. And a notebook to record your findings, your data, your analysis, what we observed during the experiment. For my procedure, step 1, we are going to be gathering our 15 agar plates, and we are going to be going to the same place, and we are going to be taking some bacteria from that same place, try to use the same exact place and the same exact amount of bacteria into each plate, so that way everything's equal. So I go to the same place and I use my sterile swabs to collect the bacteria, and I put them slowly into the plates, and then I immediately close the plate, and I keep them 5 to 7 days. I kept them for 6 days, and you basically keep them until you are able to find that the bacteria is growing and that you have enough bacteria to do the testings on. After you wait 5 to 7 days for the bacteria to form, you're going to grab your foil pan, and you're going to take your wavelength UV light, and you're going to be sticking the UV light into the foil pan, so that way you have the same amount of the room. It's the same. The UV light is over the plate at the same amount in the same room. And then after you've set up the pan and the light, you're going to remove the lids of each plate of the bacteria. You have to do this one at a time, so that way the groups are exposed to different times. You're going to put the UV length light, and you're going to be opening the plates, putting the light on, and for the different time increments. For example, if you have a UV plate, it would be exposed to 15 seconds. So you would open the plate and then immediately put the light over it, and then wait 15 seconds, and then you close the plate right away after you take, of course, the UV light off, and then that plate, you give it overnight to form. Try to have it in an area with 27 Celsius overnight, and after you find that the bacteria starts decreasing, you're going to compare the colonies after and before the UV light and decide which duration killed the most amount of bacteria. For this project, I have 5 groups of testings. For group 1, I will be having it exposed for 15 seconds. For group 2, I will be having it exposed for 30 seconds. Group 3, 60 seconds. Group 4, 120 seconds. And group 5, 300 seconds. I have 3 plates that I will be testing for each group. So in total, you should have 15 plates, 5 groups, 3 plates for each group. Here are some pictures of me when I was collecting my bacteria, so that way I can do the testings. As you can see in my first picture, this is a picture of me with the sterile swab. In my first and second picture, I'm putting the amount of the bacteria that's on the sterile swabs slowly into the plates, and then I covered the plates right away, and I put them in a warm temperature place for the bacteria to grow 5 to 7 days. And these are pictures after the bacteria grew, and after approximately 5 to 7 days. This is the foil pan that I was mentioning, and I stuck the UV light into the foil pan, and then I opened the lid of each plate and put the foil pan over the plate, and I waited a amount of time based on the group that we were testing for. In the second picture, as you can see, we have a timer, so that way all our information is specific and the time is correct. And also in the second picture, you can tell that there's the bacteria on plates. I made a chart for them, and you would need a permanent marker, so that way you can write, for example, plate 1, it was exposed for 15 seconds, you can write 15 seconds, or plate 1, 15 seconds. So that way we won't mix up our plates and the exposure time. These are pictures of the before of the bacteria and the after. I took pictures of before the UV light was exposed to the bacteria. So as you can see in before group 1, and the after is on the bottom, before group 2, and after is on the bottom, and before group 3, the after is on the bottom. So if you look closely on group 1, the before, this was a picture that I took before the exposure. The after, you can tell that there wasn't much of a difference. There's still pretty much the same exact amount of colonies in the plates. And here are my groups 4 to 5, the before group 4, and the after for group 4. And then group 5 is where we really saw a difference. The most, because that plate was exposed for the longest amount of time, which was 300 seconds. you can see that there's a huge dot, a black dot in the middle of the before for group 5, and in the after, the dot, the color, it didn't completely disappear. However, the color did disappear. The color became lower black. It wasn't like as big as the black that's on the top. And you can see that the bacteria in group 5 really did start to decrease. The colonies, most of the colonies were decreasing, especially the little ones. In the before you can find that there are multiple little colonies, but in the after there were like only a couple. So here is a table of my results. For the average for group 1, which was exposed for 15 seconds, I had 0 colonies that were completely taken away or that completely were killed by the UV light. For group 2, which was exposed for 30 seconds, I have an average of 1.5 colonies. For group 3, 60 seconds, I have an average of 2 colonies. Group 4, 120 seconds, an average of 2.5 colonies. And group 5, which was exposed for 300 seconds, I have 4.2 colonies that were killed by the UV light. So you can already compare group 1 and group 5. You can tell that group 1 was a lower amount of time that was exposed, therefore there was no colonies that were killed. And group 5, the most, 300 seconds, there were an average of 4.2 colonies that were killed. Here are my charts and my data. As you can see in the first picture on the left, you can see that we start off at group 1. There are not much, there's no line, meaning that there was no bacteria that was killed. And then group 5, you can see the slope sort of. It's increasing, the amount of bacteria is increasing depending on the seconds. So group 5 was the most amount. Okay, for my data analysis. So according to my data and graphs, it can be proven and inferred that the longer the duration of exposure of UV light to the plate, the more the bacteria is killed. Since group 1 was only exposed for a short amount of time, 15 seconds, 0 colonies were killed. In group 2, the plates were exposed for a bit higher time than group 1, which was 30 seconds, about 1.5 colonies were killed. In group 3, the plates were exposed for 60 seconds, and an average of 2 colonies of bacteria were killed in each plate. Group 4, exposed for 120 seconds, an average of 2.5 colonies. And group 5, the most amount of exposure, the most time, 300 seconds, an average of about 4.2 colonies were killed. So, in conclusion, it can be proven and shown that when you increase the duration of exposure, the more the bacteria would be killed. In conclusion, my hypothesis in fact was correct, that the longer the UV light is placed over the agar plate, the more bacteria would decrease. Exposing bacteria to UVB light in different time increments will result in a direct decrease in the amount of bacteria. Bacteria is all around us. To protect ourselves from bacteria, we should take some precautions, such as washing our hands very frequently, using more frequently antibacterial wipes and hand sanitizer, and of course making sure that when we come to touch sensitive parts in our body, such as our eyes, that our hands are clean. And this experiment or this project can be furthered by maybe one day for cleansing purposes. For example, we can hang UV lights in classrooms, offices, schools, lockers, for cleansing purposes, so that way the amount of bacteria would decrease, so that way we would live in a more healthy environment. This is my bibliography. I used these main websites to help me during my research. And thank you for watching. Thank you for watching my science fair project.